right, here we go for 1.5. I will say these last few questions, these 4 questions for the quadratic formula, that will be where we spend a lot of our time. And so because of that, what we are going to unfortunately have to say is, please, please, please remember that we were supposed to review our factoring earlier on in the course in the review section. Now, with that being said, let's learn how to solve some quadratic equations. And I first want you to look at these first kind of 7 questions here. Now notice this isn't a new heading, but I'm even reordering my number here just to say this section is going to be done so differently, it's worth reordering, and that's where we'll spend our time. However, look at these first 7 questions, and I want you to maybe sit, think, pause, ask, what is the difference between the first 3 and the second 4 questions? And here's the answer. The answer is the bottom 4 questions only have a single variable x that might be squared but could be isolated. All right, now let's, with that being said, look at the top 3 and solve those fairly quickly. Again, asterisk, based on the review that we did in that first module. So I warned that that was the most important one, is the factoring module, the factoring review. Please, please, please redo it, look back, review, and then make sense of it, because it will make the rest of the course go by quickly. Let's get solving though. So this first one is ready to go. Why? Because it's set equal to 0. That's our main goal there. Now, when it's set equal to 0, we can do our factoring, and we're going to do this very, very quickly. To factor this one, we're going to ask what multiplies to 40 and subtracts to 3. And, well, let's see here. What does multiply to 40 and subtract to 3? There's 1 and 40. There's 2 and 20. Not 3. There's 4 and 10. And then there's 5 and 8. And thankfully, those will subtract to 3. And so, here's what I get. I'm able to jump right to my parentheses. Notice it's still equal to 0, because I'm just dealing with the x squared minus 3x minus 40. So I'm doing my factoring. There should be a 5. There should be an 8. Like I'm saying, when the number up front's 1, you can jump to your parentheses. The 8's going to have to be negative. The 5's going to have to be positive. And I'm going to kind of say it this way. The only way you can check that is by foiling in your head that, oh yeah, negative 8x and positive 5x does make negative 3x. And multiplying these last 2 does get me negative 40. Now, again, I'm doing that very quick from the review section. But here's the new topic from that review, is I still want to know when this thing equals 0. Now, because I've factored, I really just have 2 really quick simple equations to solve. And here's what I mean. I'm simply asking what makes x plus 5 equal 0. And hopefully you can kind of just see that pretty quick, that the answer is negative 5. And what makes x minus 8 equal 0? The answer is 8. And we don't need to do too much more writing than that. And this still, I would say, qualifies as somewhat review, but that is what makes each of these parentheses 0. And so go back and plug them in, and you'll see that it makes 0 across the board. Just make sure that when you square negative 5, it becomes positive 25, because you multiplied a negative times a negative. But trust me, those 2 will make 0 in this whole equation. And I don't try to do this often, but let's go out of order and solve this next one. I think that'll be a good next step, and we can break down maybe what went on here. So on this next one, we still have some stuff to solve, but thankfully it's already set equal to 0, so we're good to go. Notice why I left the other one for last. Well, these first 2 terms, or only 2 terms on the left, share a 6x. Whoops. And notice that this is what I'm left with after I factor it out. Now, here's what happened kind of quickly. What you do is you kind of mentally in your head say, well, what makes 6x equal 0? You also later ask, what makes x plus 2 equal 0? And the answer is, these are just 2 basic equations to solve. This one, you divide 6 and you get, well, actually still just 0. This one, you move the 2 over, and guess what? You get negative 2. And that's all I was doing on this last example over here. All I did was I was saying, well, what makes x plus 5 equal 0? Well, subtract the 5, negative 5. What makes x minus 8 equal 0? Well, just add the 8, positive 8. It's just splitting them each into their own separate equation and setting them equal to 0. And the trick is solving for when something is 0 is really easy to do if you've factored and you're only multiplying. And that's the key there. With that being said, let's take a look at this last example. So what we need to do this time is get this set equal to 0. Now, I usually like to keep my x squared positive, so I'm going to add over the 3x. I'm also going to subtract over the 2, and it's still set equal to 0. Now, I would love to review by grouping, but for sake of time, I'm not going to, and I'm more so going to move to the guessing and checking phase, which is not ideal, but it works. Now, I just got a feeling, and you've got to trust me that I haven't done it, that I think this is probably going to be a 7x and a 2x to make 14. However, it could be 14 and 1. That's what I mean by guessing and checking. You can do the whole by grouping process, review that from first module, and you'll see what to do there. But let's go on and see what I can do here. My question is this a 1, is this a 2, and can I make 7 and 4 and get 3 out of that via subtraction? That's a lot of talking out loud, but I actually guessed my way kind of to the right answer. That, I don't know, something in me just said 7 and 2 should probably be split up to get 14. 2 and 1, probably can't put the 2 here, but really, I'm mentally practicing all the foiling and going really quick. So can I make 14x squared out of this? Yes, I can. I make a 7 and a 4. Can 3 by subtraction come out of 7 and 4? The answer is yes. And can 2 come out of this final multiplication? Yes. So because I answered yes to those, now I just need to figure out which one's positive, which one's negative. Well, the 7 will need to be positive, and the 4 will need to be negative in order to get a positive 3. So 7 positive, 4 negative, and I guess I'm going to call it again, guessed and checked my way to this answer, but that is really kind of the way we do it, unless you're going to do the whole by grouping process, and the whole by grouping process can be reviewed in the first module, and that's as many times as I can say that. So now we split this up and solve each one individually. What makes 7x minus 2 equal 0? What makes 2x plus 1 equal 0? Now, to skip that again, because that should be some early review work, that's going to be, well, 2/7 and negative 1/2. Now, this is our first moment in the course where maybe we're saying, hey, factoring's nice, but that's kind of ugly answers. I don't think I would have ever guessed that unless I did this procedure. And you're not wrong, and we're diving slowly into the need for this bottom section that will take up a lot of our time through really the whole module. All right, let's go a little bit faster, though, through this other section. Now, this one's special because, again, there's no single x that isn't squared or isn't wrapped up being squared. So how do we solve these? Well, the answer is we can just isolate the squared variable and move on and move on. So this one says x, or 3x squared is 12. Let's isolate x squared by dividing. After all, they were multiplying. I get 4. Well, what's the square root of 4? Now, this is where we need to be careful. If you're solving by introducing a square root, you need plus or minus that square root. And so this ends up being plus or minus 2. And by all means, go and plug in positive 2 and see why that's true. Plug in negative 2 and see that it squares and doesn't matter that it was negative because it's being squared, and you're good to go. Now, that only works, or that's only true all the time when there's a single squared variable, is when you can get away with those arguments. Well, let's keep on going and see what happens. This one, I've got 2x squared plus 2 is 22. First thing I'm going to do is subtract that 2 over and just get 20. This 2 wasn't a part of my x, so it got subtracted first. There we go. Then I'm going to divide. That's going to give me 10. And now, although it's going to look a little ugly, I'm going to square root both sides. Because I'm square rooting to solve, I introduce a plus minus, and I get root 10. And that is my answer because root 10, there's not a perfect square hiding inside of it that I can factor out. So we're good to go there. Again, by all means, plug it back in, and really, it's probably worth your time. Plug in a square root of 10, and then square it, and see why this ends up working and being your correct answer. All right, let's look at the next one. We're going even faster. I've got 2x squared equals, if I add 9, that's going to be negative 18. If I divide the 2, because it was multiplying, I get negative 9. And now I'm going to solve this by square rooting both sides. Now by introducing a square root, I introduce plus and minus. But I've got, this time, plus or minus the square root of negative 9. Now, normally we would say no real answer, but we just came out of a section where we learned that that's really 3i. And it would be worth your time, and we don't have time, to plug this in and see why does positive 3i get squared and work out. Well, remember that I squared, if that gets plugged in, that's going to do something special, and you're going to be able to see how this answer works itself out. All right, last one, number 7. This one goes by pretty quick. Even though my x isn't like quite isolated, it is trapped within this entire parentheses, which is being squared. So my first step is still just a square root. Well, because I'm square rooting, I'm introducing plus or minus. To think out loud, the square root of 36 is just 6. And so I get x equals plus or minus 6 plus 5. Now that is your correct answer, but really that means your answer is, well, positive 6 plus 5, which is 11, and negative 6 plus 5, which is negative 1. So there's a mathy way of writing your answer and a practical way of writing your two unique solutions. All right, we've done good so far. Now, I'm trying to keep these to about 20 minutes, but this one's probably going to go 30 minutes because the quadratic formula is a beast to get through in all the different things that can show up as you're working through it. Now, when you have something, here's the idea, that looks like x squared x number in all the various forms that we've seen, as long as you can, get that equal to 0, then there's a formula that solves any problem, whether it has ugly roots, whether it has i's that show up, whether it has ugly fractions or whole numbers or zeros or negatives or positives. The quadratic formula solves them all. And so in one sense, it's the only thing you need to learn. In another sense, it's far more practical to do everything we did in these first 7 examples than it is to do the quadratic formula. But if none of these others work, let's say it this way, if there are no factors of 40 that subtract to 3, or if there were no factors of 40 that subtract to 3, then the quadratic formula is what you go to because it will solve it anyways. It will give you the ugly square root or I answer, even though the factoring didn't work. Now, it is a formula, and you are going to need to memorize this, and the formula looks like the following. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Like I said, this is a beast of a formula, and it's not that easy to work out after you've substituted all the time either. And that's what we're going to be spending the majority of our time doing is, how do I work through this formula? So here we go. First, let's identify a, b, and c in this first problem. Well, a is 1, because that's the number in front of x squared. B is 9, because this is the number in front of x. C is 1, because this is the number by itself. And 0 is on the other side, and that's why I was able to look and call out these numbers. Well, now it's time to carefully substitute into this formula. That's step 1. Directly substitute. I'm going to use kind of like an arrow to say here's step 1. So when I directly substitute, negative b is negative 9. Plus or minus square root b squared. What is b? Square it. 81. Now when you square it, it'll be positive no matter what, because you just squared something. So, it'll be a negative times a negative or a positive times a positive. Then I've got negative 4 times a times c. A is 1, c is 1, all over 2 times A. So that is step 1. It's initial substitution. Now notice I handle my negative or double negative if it shows up. I handle my squaring knowing it's going to be positive. Now what's my next step? My next step is get one number in the square root. So when I do that, 81 essentially minus 4 is 77. Now thankfully, 77 doesn't work out, and on the bottom, 2 times 1 is 2. And so guess what? Because there's no perfect square factor hiding inside of 77, and just caveat saying that out loud earlier. Where did that show up earlier? Earlier, in the last video even. When we had, yep, there it was. When we had negative root 12, remember we pulled the perfect square 4 out of the 12 and then kept the 3. But 77, there is no perfect square inside of 77. So actually at this point, we're done. This is my answer. You're allowed to type it in. You should be able to type it in like this with the plus minus symbol in your work, and that's considered correct because you technically gave both answers. And like I said, that was the warning is, hey, look at all these problems. There's answer 1, there's answer 2. There's answer 1, there's answer 2. There's answer 1, there's answer 2. There's plus minus, which must mean answer 1 and answer 2. So all these questions should have 2 answers, and here it is, the plus or minus making 2 answers that you would normally write out 1 positive right here between the negative 9 and the root, 1 negative between the negative 9 and the root, all over 2, and there you go. Okay, now that was example number 1. We're going to try to do these quickly, but again, these are really kind of the most intense parts of the course we've gone through so far. So, in this next example, we need to look up and realize that our definition says I need to be set equal to 0, and I'm not. So some things have to move over before I can assign A, B, and C. All right, I've moved everything over. I can now know that A is 2, B is negative 8, and C is negative 3. All right, our next step is substitute. So negative B, negative 8, is positive 8. Plus or minus the square root of B squared, negative 8 squared. That's 64. It's always positive because you just squared it. Minus 4 times A times C. There we go. All over 2 times A. All right, so again, that's step 1 after you isolate and get it equal to 0 is find A, B, and C and plug them in. Again, I usually double negate my B or negate my B as needed. I square it right away, and I pretty much leave everything else untouched. And that leads us to the next step, which is one number in the square root. That's always your next step. Well, 64 and what will be plus 24 is 88. And that's all over 4. Now, this is where things get a little bit tricky because you're going to be tempted to say, ooh, 88 and 4 and 8. Don't those all reduce? Now, in normal circumstances, they would reduce, but in this case, they're not going to. Why? Because 88 is inside of a root, so it is safe from any division or reducing that's going to occur. However, let's think about 88 for a second. Is there a perfect square possibly hiding inside of 88? And I'm pretty sure there is, because, let's rewrite it, I'm pretty sure 88 is 4 times 22. And 4 is, of course, a perfect square. Well, watch what happens now. I now get 8 plus or minus 2, because that's what 4 roots to, and now it escapes. 22 all over 4. And we're still not done, but watch this and catch this argument. Now there's an 8 on the outside in the first term. There's a 2 on the outside in the second term, even though it's separated by a plus minus. There's a 4 on the outside on the denominator, and 8, 2, and 4 all on the outside. Each term on the outside, all is divisible. So now I can reduce by 2, and 8 becomes 4. 2 becomes 1 out front, so I don't need to write it. And 4 becomes 2 when I reduce. And this is my final answer. Like I said, this is why we're spending a little longer on these. There's a lot of stuff to handle here. Initial substitutions, negating, squaring, getting one number in the root. Careful with that substitution and working out. That is, let me just double check. That is 12 times 2. That is 24, which would be 88. Yes, I trust myself there. Then there was a perfect square hiding inside of my root. I took it out and then rooted it. Then I could reduce afterwards. There's a lot of steps here, and we've got 2 more to go, but it's worth our time to review it together. All right, so we're going to go through these last 2 fairly quick. Here we go. We're going to subtract to move everything over to one side so it can be set equal to 0, because otherwise we can't use the quadratic formula if it's not set equal to 0. And let's get going and start substituting. So negative b will become positive 25. Again, I'm not going to write a, b, and c, but they are what they are in order. 25 squared is, I think 625. I'll double check myself in a second here. Minus 4 times a times c. Nasty. All over 2 times a. Let me double check. All right, it was 625. And now, 625. And now I need to get one number inside the square root. And that number is going to end up being 529 when you work it out. That's all over 12. Well, I'm now left figuring out sorry, I should give some more space here. Can let's reduce any further. What is the root of 529, or is there a perfect square hiding inside? I'm again going to pause and figure that out. Wouldn't you know it? 529 square roots perfectly to 23, so the root is gone. Now this hasn't quite happened yet so far, so there's still, again, more stuff to see. We can do this pretty quickly. What this is doing is this is saying there's 2 answers, there's 2 branches. There's one where it's 25 plus 23, which is 48 over 12. There's another version where it's 25 minus 23, which is 2 over 12. And so what does that make my answers? It makes my answers 4 and, let's see here, 1/6. Now here's what I don't have time to fully process out for you, but you need to know, is that if I got 4 and 1/6 out of this, then evidently this could have been factored by grouping, and the quadratic formula was, in a way of saying it, overkill, because there should have been an easier way to find 4 and 1/6. And the answer is factor this by grouping and see how that works itself out. However, the quadratic formula maybe isn't overkill because it solves it no matter what, whether i's come out, roots stay, or it is just regular numbers and fractions. So let's look at one more, number 4 here. And whoops, that should still say equals 0. All right, now this last one is going to be pretty nasty because the numbers are going to get pretty big. However, we're not afraid of hard things, especially because we have a calculator. Thankfully, again, please write in the equal 0, but thankfully, we're already ready to dive into our quadratic formula because it's already isolated. So let's see what we can do. We've got negative b, which will now be positive 36, plus or minus the square root of 36 squared, so that's my first big number here, which is going to be 1,296, my goodness, minus 4 times a, which is also 4, times c, which is 71, oh gosh, all over 2 times a. All right, well, what's next? Well, what's next, as we've said, is get one number in the square root. Let's figure out what that one number is. Got 36, I've got 8 on the bottom. So 1296, let's see here, minus, how do I want to work this out? That's going to be negative 16. I think is how I'm going to look at this. And then times 71. And then plus 1296, because of how my calculator has it. This is equal to root 160. Okay, now root 160. Well, when I look at 160, here's what that screams out to me. It screams out 16 and 10. So it looks like this could be 36 plus or minus 4 root 10 over 8. And now finally, I think I'm ready to reduce, because this is going to be, well, 36 over 8. Those have a 4 in common. That'll be 9 over 4 plus or minus, well, again, 4 in common. So 1 root 10. And this is going to end up being your final answer. So all I did there at the end there, again, my 16 rooted the 4. My root 10 doesn't have any perfect square, so it stays. But 36, 4, and 8 all have a 4 in common, so they all got reduced by 4. Whoops, reduced by 4. There we go. Glad I caught it. That'll be 2, because 8 divided by 4 is 2. All right, and there we go. Thanks for the little bit of extra time here on this one. But the quadratic formula is super, super important. I want to show you, just real quick, a website that I like very much. So this website, I can just type in that equation, and it already thinks I probably want to solve it. And so there's your 9 over 2. Now, this is what looks a little bit different, is they somehow turned that into plus or minus root 10 over 2, all in a root. But we as mathematicians would say, well, I don't like that, because there's technically a root on the bottom there. And so our answer is equivalent, but I guess what I'm saying here is, by all means, check your work, but just know that even this website, which I've used for years, doesn't write it as root 10 over 2 entirely. We're both correct, but I would argue we're more correct because we didn't keep a square root technically in our denominator. We worked it out. So just bear that in mind, that if you are using online tools as you practice, that's fine. I encourage it. But you might see some different results in your quadratic formula. Now, different in expression, but equal in worth is the key there. All right, thank you, and I'll see you for a quick recap on 1.6. Or not recap, but quick go through.